Hello dear students, welcome. Am I audible and visible? Am I audible and visible to you? Yes. Am I audible and visible? So, shall we start now? So, as you know that we are just starting a new chapter, right? Capacitor. So, we are going to start a new unit with capacitor. One second. Capacitor. One second, beta. Okay. So, let's start now. Okay. Hello, beta. You are late. You are a couple of minutes late. So let's start a new chapter known as capacitor. But you will find this portion of syllabus in your second chapter of your NCERT. That means electric, potential and capacitance. Okay, but here for any computer examination, we are taking it as a different one. So there is a reason why we take this chapter after the current. You will get it, no? Okay, look now. So what capacitor is all about? So we will be going with some definitional part or some basic part of capacitor. Then you will get a very good understanding of regarding capacitor, right? So what capacitor is everything. So first of all, we will be discussing about capacitance. Capacitance or capacity or capacity. Okay. Don't rush. Be some patient, right? Have some patience. So we know that, let us suppose we have a conductor. Suppose we have a conductor. It is a conductor. This particular is a diagram of a conductor. You know from the electrostatic that if you are giving some charge, we are giving some charge to capacitor. Charge plus charge given. I guess the whole charge will reside only on the outer surface. Okay, I guess the whole charge will reside only on the outer surface only. Okay, inside charge inside will be equals to 0. Why, sir? Property of a capacitor. To minimize the electric potential, charges try to be on the maximum distance, that is only what? Surfaces. I guess if you have seen lecture number of electrostatic, last point we discussed about charges. Why charges reside only on the outer surface. If you can see now more clearly here, this point I have just drawn charge particles very close to each other, and here charge particles are very away from each other. Do you know the reason behind it? Reason behind it is charge density. Charge density is inversely proportional to radius of curvature. This point we already had discussed about this particular point, and this particular point was asked in your NEET examination. What is this? I guess you know it, no? Because we discussed each and every point in our electrostatic chapter, and some part we discussed in current electricity. Now let us do one thing. Let us do one thing. Let us increase charge, increase charge. That means if let's say we give 1 coulomb, now we increase it to 2 coulombs, 3 coulombs, 4 coulombs. What happens now? What happens now? More charge, you will increase. I will increase more charge, more electric field around, more electric field, more charge, more electric field. We know it now. Due to charge, electric field is present. Increase charge now. Now you increase more charge, more electric field. There will be a point. There will be a point. No, we have surroundings here. Surroundings. These are surrounding atoms. Surrounding atoms. Surrounding or air particles. Okay, air particles. What happens now? When you increase the charge, electric field increases. Electric field increases. First of all, this particular diagram represents my ear. Suppose it is air particle. Suppose now. But when we create a charge, when we create an electric field here, look, when we create an electric field, this electric field, what happens next? It is not visible now. I will make it here. Look now. If initially it is initial air particle, initially air. Okay. Then you increase the electric field. This is my electric field. Due to this electric field, what happens? Here the positive charge will experience a force away from it, and negative charge will feel exposed like this. So now next step, my air particle will become like this, positive and negative. Next, my air particle will become like this. Okay. Now more. What happens now? You increase more electric field. More. What will happen now? There will be a point where this air particle will break down. This air particle will break down. Now we have negative charge particle and positive charge particle. This will go along the electric field. This will go towards your electric field. That means now, sir, look now, this would be negative and this is positive. Negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, and so on. Okay. This process of aparting the poles, this process, look, it was coinciding now you separated the poles. This process is known as polarization, creating poles. Initially it was only a air particle with no charge. Now you separated the charged particles due to the external electric field. There is now positive and negative. Net is zero, obviously. But there is a charged particle of negative and positive away from their centers. So this particular thing known as polarization. Now you are increasing electric field. More electric field, more force of attraction and repulsion. So there will be a one point where your particle will break down. This particle will break down. Next up, particle breakdowns. This particle breakdown, right? Now next step, what happens now? I guess this one is positive, negative. Positive repels, Positive repels, but negative gets attracted. So this negative will be on this here. So negative will be get what? Attached. This negative will get attached to your surface. It will get attached towards your surface, right? Suppose initially you have plus 10 q charge or 10 coulomb. Let's suppose you have charge 10 coulomb initially. Next part, what happens? These negative charges get attracted towards surface. These are, let's suppose, minus 3 coulomb. So what is net charge on surface? So net charge is plus 10 coulomb minus 3 coulomb. So it came out to be plus 7 coulomb. Due to this process, charge decreases. When you are placing like this and when you are giving more charge, more electric field, more polarization, particle will break down, then charge decreases. This decrease of charge is known as what? This whole process is known as what? Any idea? Huh? We are called this process as a charge leak. This particular thing means charge leaking. If somebody will ask you what does charge leaking is meant of, right? You need to write each and every detail of it. Basically, charge is not leaking from your conductor, from the surface, from your surrounding, from your ear. No? Negative charge particles get attached towards the surface of the conductor, hence net charge decreases. So we are thinking that, oh, initially it was 10 coulomb. So how it becomes 7? We are just imagine now the charge must have leak. But what is the science behind it? Sir, negative charge gets attached towards the surface. Easy? Easy, beta? Easy or super easy? So, Laksha Chaudhary, sir, thank you for teaching us free of cost. No issue, beta. No issue. Done? Any issue up to this particular point? Okay, now, look now. This was all about charge leaking. Now, what you need to learn from this particular slide, that is, if we are giving charge, potential will increase. If we are giving charge, potential will increase. If we are giving charge, potential will increase. That simply indicates my charge is directly proportional to my potential. So if we are having this particular sign in physics, we need to change it. So this thing is, we need to write it equals to with some constant. Every time, no? If you need to replace this constant thing, proportionally constant, you need to just exchange it with the equal to sign with some constant. So I will write here, sir, Q is equals to proportionality constant, that is C into V. Okay, sir. What is Q? We know that Q is charge. Q is charge. What is V? Sir, V is potential. V is potential. Sir, what is C? C is a constant. C is a constant known as capacitance. Known as capacitance of conductor. Capacitance of conductor means capacity of the conductor to hold the charge. Capacitance, right, of a conductor means your capacity of the conductor to hold the charge. That means if you now need to define C, so I guess from this equation, capacitance of conductor is a ratio of charge divided by potential. C equals to Q by V. First class is basic, that's why I'm going too slow in the class. Hello, beta. Vinay Kumar. First class, I will be doing a basic things. From next class, the rocket thing, right? Be in the class. Be in the class, and we are discussing from the basics. With every and each important derivation, we will do in the class. Now, if you need now, sir, how to write it? So it is unit. It is unit. The unit of capacitance. As we know that we are having two types of unit. One is MKS, also known as SI. Second one is CGS. Second one is CGS. In SI or MKS, it is farad. It is farad. In CGS, it is stat farad. It is stat farad. And the relation means 1 farad is equals to 9 into 10 to the power 11 stat farad. This relation you need to memorize now. Easy, no? I guess when we are dealing with the electrostatic, there are also charge about no coulomb, stat coulomb, absolute coulomb, and in some books you will find the Franklin also, the smallest one. Okay, done up to this particular point. Any issue up to this one? If you have, you can ask me now. I am the class. Ha, Vinay Kumar beta. I told you, in backward that I am going to start foundation. That means 9th, 10th, not for boards, for JEE and NEET, right? I will be starting the course. But due to some work, I am just having a lot of class in a day, right? Because I am not teaching on YouTube, YouTube, it is some sort of for my, what to say, I love to teach, but my primary job is also teaching, so I'm having a couple of classes in a day. So my energy and all these things is getting utilized. So my primary goal is to firstly complete 12th. After 12th, we will start. And in coming days, we will be completing 12th. Okay? Don't worry, Don't worry. Before your examination, we will complete whole syllabus of 10th and 9th also. Don't worry about it. Okay, now, second part. So first thing we discussed it now, it was capacitance or capacity. Now second part. Second part that we will be discussing, it is what? As you know that now beta, we are not discussing here some basic things, not the very minute things. Why? Because I hope that you are studying from any NCERT, from any government school, private school, from any institutions, so you will have a very basic definition of it. Basic definition means what capacitor is basically. Okay, you will get to know now what capacitor is. So what is capacitor? If you can look towards your fan now, if this is your fan, fan, so you will find here a small sort of cylindrical thing here. If you can see your washing machine, you will find something like that. Okay, inside it. If you go inside the cooler, you will find like this, right? So basically, capacitor is a device. No, better. I guess if you are in 10th right now, and you will be having examination in 2026. I guess if you are in CBSE, if you are on state board, your examination will be in last months of the 2025. So before that, I will just complete the whole 10th. Don't worry about it. So what capacitor is basically? Capacitor is a device which we are using to provide sudden energy. Sudden energy. So what does it mean? Suppose there's a or a bus. Car or a bus. Okay? And it gets stuck. It is not moving. Not moving. The bus is not moving. It is not moving. If we are, let's say we are just pushing it now. We are pushing it. It is not still not moving. One more person. We are pushing it. Still not moving. But one more thing, it is not moving. Then when what we are doing now, we are going in a resonating phase. That means we are applying push at that particular time. Okay, let's suppose we are going 1, 2, 3, push it. I guess you have experienced this thing, no? So when we are pushing it now, at that particular moment we are giving maximum force. We are giving maximum force. Now it starts a little bit. It started a little bit. Now we don't need to apply this particular force. Why? We are then applying regular forces. You can get it now, beta? Definitely. You can have it the experience now when we are trying to drag something, when we are pushing something, or when we are pulling something from firstly from first thing. No, that means when we start pushing or pulling at that particular time, it needs more force. It needs maximum force. It needs maximum force, right? Okay. But when the particular body starts moving, then it doesn't need that much of force. It still needs force, but not that much of force. In the same way, if we want to rotate the fan, at the first instant, it needs more and more and more energy to do it. It needs more force to rotate it. Once it starts a little bit of rotation, then it needs a regular force. So capacitor acts here a energy booster. It gives a sudden energy to it, to your fan, to your refrigerator, to your this cooler, to your washing machine. No? It gives at a sudden sort of energy release. When your fan rotates, now it takes a current, it takes energy from current, not the usual one. It rotates. So this particular device name is capacitor. In some places you will find it is named as condenser. If you just go to your repair shop, na, so there those people are called it as a condenser. Done. Done now. Okay, now we will start a type of this capacitor known as parallel plate capacitor. This is parallel plate capacitor. Parallel plate capacitor. You can see here, no? A name indicates parallel plate. So it requires two plates, but these two plates needs to be parallel to each other. So let's make it one plate like this, one plate like this. Now we connect these two plates to our external circuit. So we will give plus charge to this one, minus charge to this one, and whole charge will be concentrated to inside plates only. And the reason behind it, we discussed it in our electrostatic. If you don't know, I will be giving a quick recap. Charge Q, charge minus Q. So here will be charge Q minus Q divided by 2. Here Q minus Q divided by 2. So it will be 0 by 2, 0 by 2. So charge on this particular plate is 0. Here is 0. So all charge will be inside. That's why, no? That's why I was just telling you in the back sessions, better be in the class, be attentive. You need to think about each and everything. Okay? And if the area, these plates, now basically these plates are like this. Okay? But we are seeing these plates from this angle. These plates are like this. Now look, if you can see now, it is like this now. But we are seeing these plates in this way. So you can see area. These are plates. So I can write the area of these plates is A. And the separation between these plates are given as D. It is separation. This one is separation. This one is separation. Done? And we had, I guess, discussed many things now. Sir, what? Electric field inside it. Okay. So electric field will be, look, due to positive in this way, Due to negative in this way, it is E1 plus E2. So what is my E net? Sir, E net is equals to E1 plus E2. Done. Both are same. So it will be how much? So E1 is how much? Sigma by 2 epsilon naught plus sigma by 2 epsilon naught equals to sigma by epsilon naught. This thing we also done in electrostatic. Done, no? This thing we also discussed in electrostatic. Find electric field in your infinite charged sheet. Done, madam? And what is the sigma now? This one. This one. Charge density, or more accurately, surface charge density. Surface charge density equals to charge by area. So sigma is equals to charge is Q, area is A. It is Q by A. It is Q by A. So what is change in potential? It is electric field into distance between the plates. So these things you need to get from your previous chapters. Done? Okay. Let us derive some formulas from this particular slide. Look better. Done now? Look. What is E net? Sir, I guess E net is equals to sigma by epsilon naught. Done? Okay. What is delta V? Sir, it is E into D. What is E? It is sigma by epsilon naught into D. What is sigma? It is Q. It is Q by A epsilon naught into D. This is equation for my potential difference, delta V. Done? Okay, look now. What is C? C is capacitance, which is Q divided by V. What is Q? Sir, Q is Q. What is V or delta V? It is Q D divided by A epsilon naught, which is equals to Q A epsilon naught divided by Q D. Q cancel out, so my C came out to be A epsilon naught divided by D. Most important formula till now. This one. Then, if somebody will ask you, beta, what is capacitance of parallel plate capacitor? This thing is known as capacitance or capacity of parallel plate capacitor. Capacitance of a parallel plate capacitor. Done? We completed second point, now third point. Third point. We are going point to point, right? So that you will have a very systematic notes. Then we have now energy stored. Energy stored. Look now, what does this energy stored mean? Look now. One plate, one more plate. Here we have battery V. What happens here? What happens here? So we are having charges, no? We are having charges on the plates. Usually, no, normal, neutral plates, but it does have charge, no? So what happens now? What happens now? This positive terminal, done. It brings a charge minus Q here. Look now, and it puts here minus Q here. Okay, but for second charge, if we place second charge also now minus Q. Look, negative repels, but still charges are coming. Why? Because your battery is pushing the charges. This battery is actually pushing the charge. No, you need to get into it. It is pushing it. It is doing work done. So your battery is taking a charge and putting the charge on the plate where we have multiple charges already. So this battery is overcoming the repulsion between those charged particles. So this battery is doing work. Okay. So I can write now, sir, small amount of charge doing by the battery equals to V dq. Done. But we don't need a small work done, we need a total work done. Why? Because this work done gets converted into the potential. I guess back in our electric potential topic of electrostatic, work done by the external force, right, gets converted into the potential U, K, Q1, Q2 by R, right? Look now. It is not, look better. It is not like you come to my class of capacitor, now you are just taking my class, but if you have not completed electrostatic and your current, no, I guess you feel very difficult. Why? Because I am writing the formula dw equals to v dq. You will tell me, sir, how this formula is there, no? For that thing, you need to go back to the electric potential topic of capacitor. Then, okay. So, what is the integration of dw? So, that is w only. What is v? It is q by c dq. Done? Or if you can write small q, there is no issue. I can write small q, right? From the charges, initial charge is 0, final will be plus q. Okay, so W came out to be, look, capacitance is constant, integration of q with respect to dq. Okay, so I will write here, what is the integration of x with respect to dx? Sir, integration would be x square by 2. Then now, in the same way, W equals to 1 by c, then q is q square by 2, upper limit is q, lower limit is 0. So I will write W came out to be, sir, 1 by 2c, then q square, upper limit is q, lower limit is 0. So W came out to be, sir, 1 by 2c, then we have q square minus 0 square. So it came out to be 1 by 2 q square by c. Clear? And this work done by your battery gets converted into the energy known as potential energy. It is U equals to 1 by 2 q square by c. Q square by, okay, now. So we got one formula, U equals to 1 by 2 q square by c. Done? But we know one thing, sir, what? We know Q is equals to CV. So now place it, no? So I can write 1 by 2. Q is, it will be C square V square by C. C cancel out. So my answer came out to be 1 by 2 CV square. So one formula, second formula. Then one more formula. So we can write C is equals to Q by V. So U equals to 1 by 2 Q square by C. I can write 1 by 2 Q square divided by Q V. It came out to be 1 by 2 Q cancel out. It is Q into V. Third formula. So we have now three formulas. So we have three formulas. 1 by 2 Q square by C, 1 by 2 CV square, 1 by 2 QV. Based on the input is given in our numerical, we need to apply our equation. We need to apply our this thing, right? Now, I guess we are done with third. Now, fourth one. Fourth one is energy density. Energy density. Energy density means energy stored around you per unit volume. So I guess it is energy per unit volume. Per unit volume. Okay, if this is your sort of capacitor, area is A, distance is D. What is volume? Sir, volume is A into D. Volume is A into D. Done? A into D. Okay, look now, look now, look now, look now. So what is U? Sir, U equals to 1 by 2 Q square by C. Okay, U, 1 by 2 Q. What is Q? Sir, I guess Q is Q, no? Yes, I will write Q square. What is C now? I guess C is equals to A epsilon naught by D, capacitance of parallel plate capacitor. So I will write A epsilon naught and D I will put upwards. Done? An issue now? It is Q square A epsilon naught into D. Now look now, look now, look now. One more thing now. What is E? Sir, E is equals to sigma by epsilon naught. E, what is sigma? It is Q. So I can write Q divided by A epsilon naught. What is Q? It is equals to E A epsilon naught. So I guess I need to write the equation as 1 by 2 Q square. Instead of Q, I need to write E A epsilon naught square. Then divided by A epsilon naught into D. So now it is 1 by 2 E square A square epsilon naught square A epsilon naught into D. 1 cancel out, 1 cancel out. So I guess I need to write U equals to 1 by 2 E square A epsilon naught into D, right? Done. And what is volume? A into D. I guess I need to change these two now with V. No issue. So U equals to 1 by 2 E square epsilon naught into V. So now take V here. Left side it is U by V equals to 1 by 2 E square epsilon naught. So this term means it is energy per unit volume. It is what? Energy by volume. This one is energy. This one is energy. Just give me 1 minute. Clear, Veda? You are just writing so much things. Yes, my surname. Okay, you are having your own chit chat now. Done? Any issue? Oh, if somebody will ask you what is the unit of it, look, for energy it is joule volume meter cube. Clear? So how many points is 4? Now fifth point. Fifth point, beta ji. Fifth point. Fifth point. We have combination. What we have now? Combination. Combination. First part. Parallel combination. Parallel combination. Parallel combination. That means one capacitor, second capacitor, third capacitor. Clear? This one is C1, C2, C3 connected with an external voltage V. V. Look here. If charge Q is going Q here, so the charge is same as Q here. It will go into three parts: Q1, Q2, Q3. So total charge Q is equals to Q1 plus Q2 plus Q3. What is Q? What is Q? CV. It is CV. So I will write C net into V. Look better. Why? If they are parallel to each other, so potential will be same across it. So I will write Q1. It is C1 into V plus C2 into V plus C3 into V. V cancel out. So my C net came out to be C1 plus C2 plus C3 and so on. So you can okay. So basically this capacitor cases and the resistance cases are opposite to each other. In a resistance, when we are finding the equivalent resistance, it was 1 by R equivalent equals to 1 by R plus 1 by R2 plus 1 by R3. But in parallel combination of capacitors, it is C1 plus C2 plus C3. If we are having, if n identical, capacitors, so what you will write, sir? C net equals to n times C. How? Because C n times, so it becomes n times C. It becomes n times C. Done. Second case, series combination. Series combination means like this, no? 1, 2, we are taking 3 now for easiness. Potential V, C1, C2, C3, V1, V2, V3, Q, and Q will go same. So what is different here? What is different here now? V. So I can write V equals to V1 plus V2 plus V3. So Q equals to CV. So V equals to Q by C. What is V now? It is Q. So it is Q by C. C net. V1. It is Q1 by C1. Sorry, it is not Q1 by C. It is I guess charge is same. No, it is Q only. No, because same charge flows. Q plus Q by C2 plus Q by C3. Look, now cancel out. So 1 by C net equals to 1 by C1 plus 1 by C2 plus 1 by C3. So this case is same as the parallel combination of resistors. Sorry, yeah, parallel combination of resistors, but here is a series. So these are what? Opposite to each other. So if we are having C net for identical capacitors, it become C by N. It become C by N. Clear it now? Any issue now? Is there any issue? If yes, then you can ask me now. Huh? Any issue? Okay. Look now. How many points? 5, 6 point. 6 point. One thing now. Let us suppose we have a plate. One plate, one plate. On this plate, it is plus Q charge. On this plate, it is minus Q charge. So plus Q charge is on this side. Minus Q charge on this side. And we know one thing, that, sir, what? Positive, negative attracts. Positive, negative attracts. Positive, negative attracts. But why they are not attracting each other? Because we just place them fixed. We place them fixed. It's not fixed, no? We had played them fixed. That's why they are not going away from each other or into each other. Well, because we have fixed these things, right? Okay. Now, but still these plates are applying force on each other. Still, no? Still it is, let us suppose we are having two magnets, right? Just place these two magnets into your two hands. So with your hands, is, what happens to it? Now, one time, beta. My screen gets 1 second. What happens to it? Okay. If let's suppose we place two magnets in our hands, no? Okay. So we fixed these two magnets with our hands, but still we feel one thing, now. Either these two magnets are pushing each other or these are attracting towards each other. They are not going into each other now. Why? Because we had placed them fixed in our hands, but still they are just experiencing some force, no? In the same way here, two plates experience force. but they are not colliding just because we place them fixed. Okay, that means, sir, force experienced by second plate due to first is equals to charge on second plate and electric field of first plate. Charge on second plate, electric field of first plate. Okay, sir. Q is Q. What is E? What is E? Sir, we know that here there will be two electric field, E1, E2. E1 is sigma by 2 epsilon naught. E2 is sigma by 2 epsilon naught. So here I will write sigma by 2 epsilon naught. So force will be equals to Q sigma by 2 epsilon naught. Okay, sir. Is there any way to just simplify it? Yes. Sigma is equals to charge by area. So I will write force is equals to Q. Charge is Q divided by 2 epsilon naught, which is A, which is equals to Q square divided by 2A epsilon. This one is force. And you can see here force is independent on the distance between these two plates. Between these two plates. And this was asked in your NEET. Okay. So you can see, no dependency on D. At the end, you will tell the paper is so tough now because you are not paying attention to these minute things. If you are paying attention to each and everything now, so you are thinking, no, sir, force is important. How to understand it now? Look, force, it depends on Q charge, area, the permeability, right? Look, what is Q? Sir, Q is charge, A is area, it is permittivity, 8.8. Okay, done? Okay, sixth point, seventh point. Heat loss. Heat loss. Whenever current flows through any circuit, whenever current flows through any circuit, there will be a collision due to which heat gets liberated. That means heat loss is there. Heat loss is there. Okay. What is work done by battery? Work done by battery. We did discuss it now. Sir, work done by battery is charge into potential. What is charge? It is capacitance into V into V. It is CV square. That means your battery work done is CV square. Your battery work done is CV square. But do you know what is the energy stored by your battery? Energy stored. I guess we discuss it now, no? Why will we discuss it? Energy stored? Yes, sir. This one is your energy stored. It is 1 by 2 CV square. Okay, I will write here, sir, it was only 1 by 2 CV square. That means if we are giving 10 joules of energy, if we are giving 10 joules of energy, only 5 joule is saved. Where is next 5 joule? Sir, that next 5 joule gets into heat production or heat liberation or heat loss. So you will write heat loss. You will write heat loss is equals to work done by battery minus energy store. That indicates it is CV square minus 1 by 2 CV square. Therefore, my heat loss is equals to 1 by 2 CV square. It is 1 by 2 CV square. It is very easy. 1 by 2 CV square. Okay? No, I will tell you now. Do you know what is voltage division rule? What is current division rule? Okay, that thing we discussed in our current electricity. We discussed that thing in current electricity. How, sir? How that is helpful here? Look now. Option number 8. Okay, that is voltage I will revise that thing. Voltage division technique. Voltage division technique. That is, look, V R1 resistance R2. We know that sir current flows through same current. Okay. So potential across this one is V1, across this one is V2. Ohm's law, V equals to IR. I is same to V proportional to the R. So what is V1? It is R1 divided by R1 plus R2 into V. What is V2? R2 divided by R1 plus R2 into V. Okay. In the same way, if we are having capacitor here, these are my capacitors. Capacitance of this one is C1, it is C2, V1, V2 and V. Done? Look, same charge Q flows, Q flows, Q flows. We know that sir Q equals to CV. Q is same, so C is inversely proportional to V, or V is inversely proportional to C. That means V1 is equals to C2 divided by C1 plus C2 into V. And V2 equals to C1 divided by C1 plus C2 into V. Okay. Okay. If now you are done up to this particular thing, now let us discuss some numericals. Let us discuss some numericals. If you have any doubt, you can ask me now. If no doubt, then we will start. Okay. Look, beta. Let us write a numerical. My numerical. 22 volt C1, C2, C3, C4 and 2 microfarad, 3 microfarad, 6 microfarad, 11 microfarad. This one is my numerical. This one is my numerical. Okay, sir. So what I need to find? I need to find potentials. If this is 22 volt, I guess this particular one, this one, I guess this one would be also 22 volt. Why, sir? It is parallel. Okay. Okay. Now this point and this point is also 22 volts. Okay, sir. But here we are having mixture of it. So what we can do? I can write this one. Now these two are in parallel, so I need to write equation for it. What? 6 plus 3, that is 9 microfarad. 9 microfarad. Okay, so it is 22 volt is net. This one is C1 with V1, C2 V2. So what is V1? I guess V1 is equals to C2 divided by C1 plus C2 into V. And V2 is equals to C1 divided by C1 plus C2 into V. What is C2? C2 is 3. Yes, it is 3. Divided by 3 plus 1 second. No, it is not. It is not 3. It is not 3 now. C1 is 2. C2 is 9. So I need to write it. Look, now I will change whole thing now. So C2 is 9. C1 is 2 plus 9 into 22. So look now here how to solve this one. So I can write it equals to 9 divided by 11 into 22. 11 ones are 11, 2s are 9 2s are 18. It is 18 volt. This one, it is 2 divided by 2 plus 9 into 22, which is 2 divided by 11 into 22, 2 to the 4 volt. That means potential across second one is 4. V2. 1 second. V1 is 18. I guess we had done something wrong. V1 18. 9 divided by it is 11 to 18 volt. Then V1. I think we had done some different thing, no, beta? Huh? No? Correct, no? Okay. So it indicates that V1. V1 means up to this one. So this one is how much? 18 volt. And these two are in parallel, no? So it will be how much? 4 volt for both of them. This is how you need to put your equation and you will get your answers. And you will get your answer. Easy or super easy? Easy or super easy? Okay. 1 second. Super easy, na? Look, somebody will just ask you now why we need electrostatic and we need the current electricity topic before this one, na? You can see now in this particular numerical it is very easy to solve, na? But how? Because using of electrostatic and using of current electricity topics. So everything in physics is related. Everything is related. Okay. Now one more numerical from NEET. One more numerical from NEET. 10 volt, 4 microfarad, 2 microfarad, 3 microfarad, 6 microfarad. Okay, sir. What we need to find? Charge through 2 microfarad divided by charge through 4 microfarad. This ratio we need to find. This ratio. Sir, how we can do this particular ratio? Look now. Look now. If Q charge is leaving your this one, here it will divide. In this way it is Q1, in this way it is Q2. 10 volt, so 10 volt will be here also, not 10 volt. What is Q? Sir, Q equals to CV. Q. What is C? C is for microfarad. It is microfarad. So I can write 4 only. It is 4 into V. V is 10. So Q came out to be 40 microcoulomb. So it is Q. Which one we got now? 4-1. So this one we got how much? 40 microcoulomb. Now through this one Q2, what we need? We need C into V. C into V. Okay, now I guess 2 microfarad, 3, 6. These are in series. So for series, what is C net? It is 1 by C1 plus 1 by C2 plus 1 by C3, 1 by C1. C1 is 2, C2 is 3, C2 is 3, C3 is 6. 1 by C net. Okay, so I guess 6 is LCM. 2 1 2 3 are 6, 3 1 3 2 6 plus 1. It is 6 by 6. So my net C came out to be 1 microfarad. Okay, now I need to write the whole thing now. How, sir? I will write it like this, in this way. In this way, right? So this one is 10 volt. This one is 4 microfarad. This one is 1 microfarad. Through this one potential is 10. This one potential is 10. Here it is Q, let's say 1. Here is Q2. What is Q2? It is C into V. C is 1. V is how much? 10. It came out to be 10 microcoulomb. So this is how much? 10 microcoulomb. So we will write it 10 microcoulomb divided by 40 microcoulomb. Cancel out. It is 1 by 4 only. It is 1 by 4 only. Okay. I know this on his first lecture, and we are taking so much things, no? So I guess in today's class we will just short something, no? We'll do last topic, then we complete it. No, last topic, and I will give you homework then. Okay, last topic. Look now. In capacitor, we done point potential method. I guess you done this one, no? Point potential method. Second thing, we done symmetrical method. Symmetrical line method. Third one, we do Wheatstone bridge. We do Wheatstone bridge. So all these three formats are applicable. These are applicable in capacitors also. All these three formulas are applicable in capacitors also. How, sir? Let us do one numerical. Look now. Okay. See, I will give the values. X, Y. 6 microfarad, 6 microfarad, 20 microfarad, 6 microfarad, 6 microfarad. Okay. One thing. We know that this is a clear case of Wheatstone bridge. We know it now. We know it. But let us do it now. How, sir? Potential here is X, so here is also X. Here is also X. Y, so here is Y. Here is Y. If A, if here is A, so A is here, A is here, A is here. B, so B is here, B is here, B is here. I will write here now. Look, X, Y, A, B. This one is between XB, XB, XA, XA, YB, YB, AY, AY, AB, AB. Okay, XB 6 microfarad, 6 microfarad, 6 microfarad, 6 microfarad, 20 microfarad. You will take now 6 by 6 is 1, 6 by 6 is 1. It is what? Balanced Wheatstone bridge. So take this one out. Now write 6, 6, 6, 6. 6 microfarad, 6 microfarad, 6 microfarad, 6 microfarad. These two are in series. These two are in series. For this one, my C equivalent equals to 6 by 2. For these two, C equivalent is 6 by 2. That is 3. It is 3 microfarad and 3 microfarad. Now, write it in this way. It is 3 microfarad, 3 microfarad. Both are in parallel. So C parallel equals to 3 plus 3, that is 6 microfarad. Easy or super easy? Easy or super easy? Okay. Let us do one thing. I will be providing the homework, then we can just end this section. Okay, homework. Okay, now sir, homework. Okay, write homework. 1, 2, 3, 4, 5, 6. A, B. Like this, like this, like this. Like this. Okay. C equivalent is 3 by 2C. Second question. One more I will write here. C equivalent is 5 by 3 microfarad. Just take screenshot of this one. Okay, question number 3. C equivalent is 2C. C equivalent is 2C. Okay. This is, so next thing we will discuss in next class. I hope we have discussed many things in today's class, and if you have any doubts or any suggestion from your end, you can just let me know in my comment box. Or if you want to ask me anything, no, you can just get my Telegram link from the channel description part, and you can just ask me your doubts. Okay. Or if you have anything that you want to ask me personally, no, so you can go to the channel description part also in Telegram. There you will find my personal Telegram link. There you can just message me. So all the best. Thank you for today's session. If you want to ask me anything, I am here for 2 minutes, then we will just complete the class. And thank you, Beta. Thank you very much from my end. Bye. Good night.